Okay, so we are looking at now sine and cosine and tangent through the lens of a function. So the trigonometric functions, and the first thing I wanted to point out is that sine, cosine, and tangent, by the way they operate and by the way we extended the definition through the unit circle, they do operate as functions, not just as simple ratios, but actual functions. And in terms of what sort of values we can input into the function, if you think about it, and I'm talking about radian measure, but degree measure as well, but just thinking radians in the case of this, all the radian measures are just real numbers. And we know that we can talk about negative angles. And so the domain for these functions are all stretch onto negative infinity. And we can go beyond 2 pi. We can go beyond 360 degrees to however many revolutions we need. We're just going around and round and round the unit circle. And so we effectively have the domain, the possible inputs into these functions as any possible real number. You know, we've got pi on 2 and pi on 3, but we've also seen that we can talk about 1.5 radians or 17 radians. We can talk about 7,200 pi, etc. So the domain is all real numbers, with a little exception with tangent, I should say. The range is not quite so simple to look at, and so when we've looked at the graph, we'll be able to determine the range a bit more. But just in general principles, I hope you can see that if x is the input, then there is definitely going to be an output. So for example, if I put pi on 4 as the input, then the output for sine is, he's got to be tripping off your tongue. The output for sine is root 2 on 2, not 45 degrees. 45 degrees is just the degree equivalent of pi on 2. The output is the result when I look at the angle pi on 4. So the output is pi on 2. The output for cosine is is root 2 on 2, and the output for tangent is 1. Okay? So you need to know these things, guys. I mean, as far as I can tell, you don't get an exact values chart on the exam. So these need to be tripping off your tongue. Okay, that makes it a relation, but a function, as you know, has to map from the domain to every element on the domain can only map to a single value on the range. Do we have that with trig functions? Well, trig relationships, we do. Pi on 4, the sine of pi on 4 is only root 2 on 2. Now, the cosine of pi on 4 maps to the same value, root 2 on 2, but that doesn't matter. And it's also true that if I go 180 minus 45, so if I go pi minus pi on 4, so 3 pi on 4, that's also root 2 on 2. But that's okay, because a function is a function if it does this, that's the domain, that's the range. And a function is a function if it does this, that's the domain, it's a range. In other words, two values map to the same point in the range. A relation is a function. A relation is not a function if it does this. Does that kind of ring bells for you? I hope it does. Okay, so the only time a function is a function is if members of the domain map to only one value of the range, which is what we have with trig functions. So they are functions. They satisfy the definition of a function. And since they're functions, they can be graphed. Okay, so let's have a look, a little bit of an explore over what the trig functions look like. And again, if you've done Maths Extended, this will be no surprise, but a nice little bit of revision just to sort of see what we can see here. So I'm going to fire up Desmos, and here we have the unit circle, and I have a pair of axes here. And the axis has been divided into pi on 2, pi, 3 pi on 2, and 2 pi. Okay, so remember, they're just values. They're the x values. Yes, they look fancy because they've got pi's, and we know that refers to radian measure and all that kind of stuff. But at the end of the day, they're just numbers. Okay, 2 pi is about 6, pi is about 3, pi on 2 is about 1.5, 1.7, something like that. They're just numbers. Okay, so that's my x-axis, and this is my y-axis. So my y-axis is going to be the output from the sine value. So as I cycle through, I'm now going to move A to 45 degrees. 44, it's close. You can see that I've got this kind of graphing happening. So as I move along here, this is 0 to 45 degrees, and I have the corresponding sine value up here. Then I get to 90 degrees, so it gets to 45 degrees, and it sort of inflects at that stage. And then I'll go to 90 or as close as I can. There we go. And you can see it's starting to taper off until it hits a top value at pi on 2 of 1. Okay, so you can see on the unit circle, we've got the y coordinate on the unit circle of 1, as we know. Sine of 90 is 1. And then we're now going, that's the first quadrant done. And you can see that sine is positive in the first quadrant, which is why we have all these positive values here. We also know that sine is positive in the second quadrant. But now, as I increase my angle, my reference angle, you know, the angle between the x-axis and the line, my reference angle is going to be getting smaller. So what do you expect to happen to the graph? It's going to take a dive like a roller coaster. So as I go between 0 and 180, uh-oh, what have I done? Try that again. Oh, man. I'm moving the wrong thing, that's why. As I move from 0 to 180, I've moved it. Sorry about that. Like so, it's gone down again. Okay, ignore the lines and stuff. It's because I moved the unit circle by mistake because I was resizing it. I'll see if I can resize it back. There we go. Good so far? So, and that makes sense in that it's basically saying that the sine of, say, 45 degrees, so there's 45 degrees there, pi on 4. Pi on 4 has this sine value, but then it has the same value here as well because it's a second quadrant angle. Okay, and this angle here is the same as this angle here because it's the same reference angle, it's just in a different quadrant. Okay, now if I move into the third quadrant, all students take care, sine is negative. So it's probably no surprise that, oh man, sorry guys. It's probably, hopefully no surprise that as I go between 180 and 270, it's now drawing itself exactly the same as this angle here, sorry, as this part of the graph here, but it's reflected down here because it's exactly the same set of values as the first quadrant, except that in the third quadrant, they're negative. And so we have negative values here. And then as I move from 270 to 180, sorry, 270 to 360, we then have it completing its negative journey back to the start again. Now that gets me back to the start. And after then, I'm going to start moving positively again. So there's our sine graph there and the shape it makes. What I haven't had a chance to do for you yet is have a look at the cosine function, and we'll look at tan separately. And I want to continue the journey to link what you're seeing there to the unit circle, and then seeing how you solve problems with your graphics display calculator as well. So I'm going to leave it there because it is time. But